Hi students, this is Alex here. In this video, we are going to find the Fourier series for the given function. As a first step, we are going to write the formula for the Fourier series, which is f of x equal to a naught by 2 plus summation n is equal to 1 to infinity an cos n pi x by L plus summation n equal to 1 to infinity bn sin n pi x by L. Here the value of 2L is 4. So 2L equal to 4, it means L is equal to 4 by 2, which is 2. So we are going to replace the value of L in f of x. So f of x is a naught by 2 plus summation n is equal to 1 to infinity an cos n pi x by 2 plus summation n is equal to 1 to infinity bn sin n pi x by 2. Now we are going to calculate a naught. The formula is 1 by L integral 0 to 2L f of x dx. Let's place the L value. So 1 by 2 integral 0 to 4 f of x dx. But f of x is made up of two parts. One is from 0 to 2, and in 0 to 2 function is x, and from 2 to 4 it is 0. So it is x dx. Then again 1 by 2 integral 2 to 4 0 dx. Now the first part alone, so which is x square by 2 0 to 2. The last part is 0. Now when I put the upper limit, it is 2 square by 2 minus 0. So we can cancel this, and finally we have half into 2, that is 1. So a naught value is 1. Now we are going to calculate an. Now an formula is 1 by L integral 0 to 2L f of x cos n pi x by L dx, and we have to use the value of L. So 1 by 2 integral 0 to 4 f of x into cos n pi x by 2 dx. We are going to split this into two parts. One is from limit 0 to 2, f of x is x, cos n pi x by 2 dx, plus again 1 by 2 integral 2 to 4, f of x is 0 into cos n pi x by 2 dx. Anyway, the second part is completely 0. We are going to use Bernoulli's formula. This is u and this is v. Integral uv dx is uv1 minus u dash v2 plus u double dash v3 minus u triple dash v4 plus dot dot dot. Now an becomes 1 by 2 u, which is x. v1 is integration of this, which is sin n pi x by 2 by n pi by 2 minus u dash, which is 1. v2 is integration of v1, that is minus cos n pi x by 2 by n pi by 2 whole square. Then u double dash will be 0, so we can complete the integration and we can use the limit from 0 to 2. And second term is completely 0 because of this 0. Now using the limit, using the upper limit, when I put 2 here, 2 gets cancelled, so sin n pi is 0. So first term is 0, and we can make this as plus. When I put 2 here, we get cos n pi. Cos n pi is minus 1 whole power n by n pi by 2 whole square. Now using the lower limit, when I put 0 for x, everything is 0. When I put 0 for cos, it is 1. So plus 1 by n pi by 2 whole square. Now this is half, and we have common denominator, so we can add the numerators. So minus 1 whole power n, then minus 1, because when I take this minus here, it is minus 1. And denominator is n square pi square by 4. And by 4 I can take the numerator as into 4. So now we can cancel this, and we have an as 2 into minus 1 whole power n minus 1 by n square pi square. If n is odd, it means minus 1 whole power odd number becomes minus 1. So when this is minus 1, minus 1 minus 1 is minus 2. So an becomes minus 2 into 2 is minus 4. So minus 4 by n square pi square. And suppose if n is even, minus 1 whole power even becomes 1. So 1 minus 1 is 0. So an becomes 0. And we are going to use, when n is odd, the value of an is minus 4 by n square pi square. Now coming to bn, it is 1 by L integral 0 to 2L f of x sin n pi x by L dx. Let's use the value of L as 2. So integral 0 to 4, we have half f of x sin n pi x by 2 dx. Now we are going to split this into two parts, 1 by 2 integral 0 to 2 f of x is x, and we have sin n pi x by 2 dx. Again half integral 2 to 4 f of x is 0 into sin n pi x by 2 dx. Anyway, the second part is completely 0, and this is u and this is v. We are going to use Bernoulli's integral. U v dx is u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 plus dot dot dot. So now bn becomes 1 by 2 u, x you kept as it is, v1 is integration of v, which is minus cos n pi x by 2 by n pi by 2. Then minus u dash is 1, and integration of this will be minus sin n pi x by 2 by n pi by 2 whole square, and u double dash will be 0. So we close the bracket and put the limit from 0 to 2. When I put 2 in place of this, we get cos n pi, which is, for x it is 2, then there is a minus 1, then cos n pi becomes minus 1 whole power n divided by n pi by 2. When I put 2 here, sin n pi, it becomes 0. And when I put lower limit, since this is x, it is 0. And since this is sin, this is also 0. So lower limit, everything is 0. So finally, this 2 will be taken to the numerator. So into 2 by n pi, and there is another 2 and another minus 1. So total it is minus 2 into minus 1 whole power n. So anyway, we can cancel this, and we have minus 2 into minus 1 whole power n by n pi. This is our bn. So now we are going to use this in our f of x. So f of x equal to a naught by 2 is the first term, but a naught is 1, so 1 by 2, then plus summation n is equal to an we got only for the odd terms, minus 4 by n square pi square. So when n is odd till infinity, minus 4 by n square pi square into cos n pi x by L, which is 2, plus summation n is equal to 1 to infinity, Bn is minus 2 into minus 1 whole power n by n pi into sin n pi x by 2. After this we are going to rewrite this, that is rearranging this. So 1 by 2. Now minus 4 by pi square can be taken common, that is taken outside the summation. Now n becomes odd till infinity, and we have cos n pi x by 2 by n square. Then here minus 2 by pi, and even that is minus 2 by pi can be taken outside. Now this is summation n is from 1 to infinity, minus 1 whole power n by n into sin n pi x by 2. This is our required Fourier expansion for the given function f of x.